Welcome to the last portion of the chapter, Air and Atmosphere. Today we will just deal with the laboratory preparation of oxygen. Okay, as I've drawn the diagram of the apparatus used in the laboratory preparation of oxygen in the lab. So we have a round bottom flask, and we have this thistle funnel. This is called a thistle funnel, a long funnel, you can see. And we have this tube, a bent tube like this. This is called the delivery tube. And we have over here a beehive shelf. This is called a beehive shelf. And we have this long apparatus that is called this is the gas jar, the inverted gas jar. Okay, this is an inverted gas jar, and we have a trough, and in it we have water. Okay, this is the level, this is submerged, this beehive shelf and the bent delivery tube is submerged below the trough of water, where we have filled the gas jar with water, inverted it and kept it. So the gas jar is initially filled with water. Okay. Now in the thistle funnel, from the thistle funnel, we put hydrogen peroxide, which is a liquid, hydrogen peroxide, and then we have already a catalyst called manganese dioxide, MnO2. Now, what is a catalyst? You must be wondering what a catalyst is. And a catalyst is a substance. It could be an element or a compound or a mixture of some substances. So it is depending upon the reaction. So a catalyst is a substance which is used to alter, which change the rate of chemical reaction. So if the reaction is very fast, the catalyst will slow down the reaction. If the reaction is very slow, it will slow down the reaction. Or in some cases, reaction cannot take place without adding that particular substance, and this substance is called a catalyst. So by definition, we can say that a catalyst is a substance used to alter, change the rate of chemical reaction, but itself does not take part in the chemical reaction. Itself does not change. It will remain as it is. Okay, it will just help the reaction to speed up or slow down. So that is a catalyst. Now what happens is, over here from the thistle funnel, what do we put? Liquid hydrogen peroxide, H2O2. We put hydrogen peroxide, and inside the flask we already have manganese dioxide, MnO2. Now the MnO2 helps the water to break up into water and oxygen. Okay, so we can write the chemical reaction like this: H2O2, hydrogen peroxide, in the presence of manganese dioxide, MnO2, will produce water and oxygen gas. Okay, water and oxygen gas. So when we balance it, so two molecules of hydrogen peroxide reacts to form in the presence of the catalyst manganese dioxide will produce two molecules of water and oxygen, one molecule of oxygen. So we are interested in oxygen. So this oxygen, the water will remain here. The water will remain in the round bottomed flask. And then what happens is, the oxygen that is produced in the reaction, now will pass through this delivery tube here. Will pass through this delivery tube. And then we have the oxygen gas passing here. So it comes down, and then it passes through the beehive shelf, and bubbles of oxygen will be collected here. Will go up to the inverted gas jar, which is filled with water. And as more and more oxygen fills in, the water level will come down. The water level which initially fills the gas jar, the level of water will now come down as more and more oxygen gets in. So at the end, what happens? All the water will Water inside the gas jar will fall, and then we cover it with the cover slip, and then we take out the gas jar out of the water. So we have a gas jar filled with oxygen. So this is how oxygen is prepared in the laboratory. Okay. Now, we can, if you want to, you can refer to activity number 5, page number 91 in your chemistry textbook. Okay. So I'll just read it through. Aim: to prepare oxygen from hydrogen peroxide using manganese dioxide as a catalyst. Materials required: a flat-bottomed or a round-bottomed flask, two-hole rubber stopper, a thistle funnel with a stopper, a delivery tube, a beehive shelf, a gas jar, a trough containing water, hydrogen peroxide, and lastly we have the manganese dioxide. Now the procedure, I'll just read it through. Take some manganese dioxide in a flat-bottomed flask. Now we put manganese dioxide, and from the thistle funnel, what do we add? We add hydrogen peroxide drop by drop through a thistle funnel. Observation: as hydrogen peroxide drops into manganese dioxide over here, when hydrogen peroxide drops into manganese dioxide, now the reaction takes place. Brisk effervescence takes place due to the evolution of oxygen gas, and now through bubbles of oxygen gas, it passes through the delivery tube, and then it passes through the beehive shelf, and the water level comes down and it is collected in the inverted gas jar. So collection of oxygen gas is collected by the downward displacement of water. As I already told you, that more and more oxygen gets in, the level of the water which is initially filling the gas jar comes down, and it falls down. As more and more oxygen gets in, the water level will fall down. So this way of collecting the gas is called by the downward displacement of water. So oxygen is collected by the downward displacement of water. Those gases which are highly soluble in water are not collected by the downward displacement of water, like hydrogen chloride gas. If you are collecting, we cannot collect it because hydrogen chloride gas is highly soluble in water. So those gases which are sparingly soluble in water or insoluble in water, we can collect it by the downward displacement of water. Okay. So with this, we come to the end of the syllabus. I hope you've enjoyed the online classes. So thank you for watching. And if you have any queries, you can always contact me. Thank you so much for watching.